Welcome to the Thread Challenge. In this challenge, you'll create and manage threads using two approaches, by subclassing the thread class and by implementing the runnable interface. Your task is to create two threads. You should make one thread subclass the java.lang.thread class. The other should be created using a runnable which you can pass to the thread constructor. This can be any class that implements runnable or a lambda expression. Each thread should have a run method. The first thread's code should print 5 even numbers, and the second thread should print 5 odd numbers. You should execute them asynchronously, calling the start method on each in 2 consecutive statements in your main code. Have your main method, after these threads run a few seconds, interrupt one or both of these threads. Your application shouldn't crash, meaning your thread should handle an interrupted exception. Go away and give that a go, and when you're ready, come back and we'll walk through my solution together. Pause the video now. I've created a new project called Thread Challenge with the usual main class and main method in the dev.lpa package. Before I start with the main method, I'll create a class that extends the thread class. I'll just put this class in the main.java source file. I'll call this class oddThread and it'll extend the thread class. In this class, I'll implement the run method to perform a task. In this case, I'll use IntelliJ's code generation tool to override the run method. I'll remove that serper.run call inside the run method. I'll start off with a for loop that starts at 1, printing every other number, the odd numbers that are less than or equal to 10. In the loop, I'll print oddThread and the current value of I. I want to call thread.sleep, so I need a try block here. I'll make the thread sleep for 1 second every iteration. I'll catch the interrupted exception that the sleep method throws, and I'll print that the thread was interrupted. Finally, I'll break out of the loop. The next class will implement the runnable class, and I'll call this class evenRunnable. Notice how IntelliJ is giving us an error. If I hover over that, it's telling me that I need to implement the run method. Instead of using IntelliJ's override generation tool, in this case, I'll just copy the run method from the oddThread class and paste it in here. I'll change the initialization of I in the for loop, setting it to 2. I'll also change both println statements to say evenRunnable instead of oddThread. In the main method, I need to create my 2 thread instances. So first, I'll set up the oddThread, and that's just going to be a new instance of my oddThread class. For the evenRunnable thread, this is similar, but in this case, I pass a new instance of evenRunnable to the threads constructor. I'll start oddThread first, and then call start on the evenThread instance. Next, I want to put the main thread to sleep before I interrupt one of the threads. This lets them do a little work first. As usual, I need a try block. I'll put the thread to sleep for 2 seconds. Next, I need to catch the interrupted exception, and then I'll just print out the stack trace. I'm going to interrupt the oddThread, which means at some point it'll stop executing, but evenRunnable should continue running. Let's run this code. As you can see, the program didn't crash when oddThread was interrupted, but rather it handled the exception, printed a message, while evenRunnable kept executing. Now let's look at this evenRunnable class a minute. It includes no additional code and really kind of adds no extra value by its existence. What I mean by that is, because it's only a run method, it's a perfect candidate to be replaced with a lambda expression. Let's do that. I'll call this lambda runnable. Now, I'll copy the for loop from the run method in evenRunnable and paste it inside this lambda expression. I'll also change the instance passed to the thread constructor to runnable so that this lambda gets executed. I'll run this. And we get the same results. Whether you use a lambda or a class that implements runnable is a matter of style. If you need additional helper methods or some state for your running method, then obviously using a class makes more sense. In the next video, I'll be talking about multi-threading and the types of memory that can be accessed by concurrent threads. I'll see you in that video.